Okay, so good day, everyone. So this is the coverage of our final exam for CT scan. So we will start with the important terms that are used in CT scan department. So the first term is matrix. So I'm sure you have encountered this in your other subjects like your MRI. So matrix, they are array of numbers in rows and columns. So they are a combination of different numbers in rows and columns. And usually you have also encountered these terms computer subject. So it measures how large the computer memory is and how many pixels can be stored in the memory. So basically matrix depends on the memory of the computer, and it determines the number of pixels that can be stored in a specific memory depending on the file. So matrix is also termed as the memory size, and usually for standard matrix na ginagamit sa medical imaging, so the memory size is 512 by 512. So for example, if we have, if we have 80 by 80 matrix, so the pixels are 6,400. So we simply multiply 80 times 80. So so to make it clear, in a matrix of 80 by 80 size, the number of pixels can be accommodated is about 6,400. Okay, so madali lang siya. So you simply multiply 80 by 80. So the number of pixels accommodated is 6,400. So in medical imaging and in other imaging modalities, so there are different matrix sizes na ginagamit sa computer. We have 64 by 64, 128 by 128, up to 2048 by 2048. So as I have mentioned earlier, the previous slide, the most common matrix size used in medical imaging is 512 by 512. But there are also some CT scan units that are utilizing 256 by 256 matrix. So to determine the matrix size, we have the formula. Matrix size is equal to the field of view, which is measured in millimeter, divided by the pixel size. So for example, if we have here, determine the matrix size if the pixel size is 0.78 millimeters and the field of view is 40 centimeters. So as I have mentioned, the FOV must be expressed in millimeter. But in our example there, so the FOV is expressed in centimeters. So we need to convert 40 centimeters into millimeter, and that is about 400 millimeters. So 400 divided by 0.78 millimeter. So we have the we have the matrix size. So we simply divide. Another important term that are used in CT scan, so again, common siya sa computers. So since CT scan is driven by computer, so it is a two-dimensional representation of a corresponding tissue volume. So when we talk about pixel, it represents a two-dimensional image or representation of a target or a specific volume or the target of interest. So pixel actually is a term for para siyang shortcut ng picture element. So each pixel is normally represented by 12 bits or 4096 gray levels. So we will not dwell more on that. Hindi ko na siya i-discuss in detail. Tandaan lang, so usually daw or normally, isang pixel is composed of 12 bits. I I hope na remember niyo yan sa computer subject niyo, or about 4,096 grade levels. So each pixel is displayed on the video monitor as a level of brightness. So yung isang pixel, makikita natin siya sa monitor during our scanning, expressed in different brightness. So, di ba, if you can see sa ating CT scan images or types of X-ray images, they have different levels of brightness, each part. So, ganun din sa CT scan natin. And on the photographic image is a level of optical density. So, take note, sa video monitor, it is a level of brightness. Kapag naman sa radiograph or sa photographic image, the pixel is displayed on the monitor or displayed on the radiograph as a level of optical density. Again na, bright siya if we are seeing the pixel in a monitor, but kung tinitingnan natin yung pixel sa radiograph naman, so it is a level of blackness or optical density. So to determine the pixel size, so pixel size is equal to FOV expressed in millimeter divided by the matrix size. So doon lang natin kinuha yung formula sa matrix size kanina. Matrix size is equal to FOV divided by pixel size. Kung gusto naman natin i-calculate yung pixel size, so we will transpose to FOV divided by the matrix size. So most scanners used in CT scan have a pixel size of 1 to 10 millimeters. So normally, if we want to have a better resolution sa image natin, so the recommended pixel size is 1 millimeter. So the smaller the pixel size, so take note on this, the smaller the pixel size, the greater the resolution. So di ba, ganun din naman sa mga pictures natin sa cellphones, yung mga squares, kapag nag-zoom tayo ng isang picture or image or photos, so kapag malalaki yung mga squares dyan, tinatawag natin pixelated, so di ba, hindi ganun yung kanyang image. Pero kapag yung pixel size niya is maliliit, so mas maganda yung image. So the pixel size depends on the matrix size and the field of view. They are directly related. The higher the field of view, the greater the pixel size. Mas malaki yung pixel size. Also, pag sa FOV, sa FOV naman, so again, for FOV, the higher the FOV or the greater or mas wider yung field of view, malaki rin yung pixel size. Sa matrix size naman, they are inversely related. So kapag ang matrix size ay mas malaki, lumiliit ang pixel size. So again, FOV and pixel size directly related. Matrix size and pixel size inversely related. Please take note of that. So for example, we have here the FOV is 40 centimeters, so it's about 400 millimeters, and the matrix is 512 by 512. So based on the given FOV and matrix, the pixel size, if you are going to compare that based on the picture, so 400 divided by 512, so based ating formula, FOV divided by matrix size. So the matrix, the pixel size is 0.78 millimeters or 0.8 millimeters if we're going to round it off. So as you can see, pag malaki yung pixel size, ayan, 1 mm pixel, and compare natin siya sa 0.5 mm pixels. Mas maliit yung 0.5 compare sa 1. So higher signals received by individual pixel, pero poor ang kanyang resolution. Pero pag maliit yung pixel sizes, lesser signals are received by individual pixel, pero maganda naman yung kanyang resolution. Kaya mention kanina, mas maliit yung pixel size, mas maganda yung image resolution. This will be your assignment. So you're going to submit this next meeting. So I will just create a link where you can submit the answers for this sample problems. Okay. So if we're going to compare pixel and voxel, so pixel, as I have mentioned, is two-dimensional representation of the image, while the voxel is a three-dimensional representation of the image. Voxel comes from the words volume element. Pixel is picture element. So if we are going to compare pixel and voxel, as you can see the picture there, so we have there the original object, then compare natin yung pixels sa voxels. Mas maganda yung makikita natin sa voxels. Mas detailed siya kasi 3D ang representation when compared to pixels. So, other term for voxel is volume element, or pwede rin siyang tawagin tissue volume of patient. So we can calculate for voxel by multiplying the pixel size and the thickness of the scan slice or slice thickness. So ibig sabihin, voxel is equal to pixel size times the slice thickness. So again, it is a three-dimensional representation of the picture or the image. So ayan yung formula, pixel size times slice thickness. So always remember, when we calculate for pixel size, for FOV, for for pixel size and FOV, dapat naka-millimeter ang linya. So if we're going to calculate for voxel size using naman, kapag hindi naman given yung pixel size, yung given is FOV and matrix size, you can also do that. So FOV divided by matrix size. Saan nanggaling yan? Diba yung ating formula kanina, pixel size is equal to FOV divided by matrix size. So again, we can use either of the two formulas. So depende kung ano yung given. So if may given a pixel size, we're going to use the formula na nasa taas. So voxel size equal to pixel size times slice thickness. Pero pag hindi naman given yung pixel size, instead ng given is or R, FOV, and matrix size, we can use the second formula. So additional assignment will be numbers 1 and 2 for voxel size. Okay? So you can pause this video para ma-screenshot nyo or ma-copy nyo yung question. So voxel size depends on the FOV, the matrix size, and the slice thickness. So based on the formula, voxel size and FOV, they are directly related. If we increase the FOV, the voxel size will also increase, just like sa ating pixel size kanina. And inversely related naman yung voxel size sa matrix size, katulad din ng ating pixel size. Because ang voxel size and pixel size are directly related. If we increase the pixel size, the voxel size will also increase. If we also increase the slice thickness, the voxel size will also increase. Okay? So again, voxel size and FOV directly related. Voxel size and matrix size, they are inversely related. Voxel size and slice thickness, they are directly related. So the FOV, so na-discuss na naman natin yung pixel and voxel size. The FOV or the field of view can be square, pwede rin siyang rectangular. So example na field of view is 25 centimeters by 25 centimeters or 250 millimeters by 250 millimeters if the FOV is square. Pero pag rectangular, so halimbawa 25 by 20. So matrix naman, na-mention natin sa first part ng ating discussion. So 256 by 256 and yung pinaka-common is 512 by 512. So there are two major image quality goals. So we need to, kapag nag-perform tayo ng CT scan examination, yung pinaka-kinoconsider natin dapat low noise. Di ba yung noise? It can produce artifacts. Hindi maganda yung ating image para siyang grainy. And dapat high ang detail. Okay? So CT slice divided into matrix of voxel. So yung ating slice thickness. So we will discuss more on that. Sa field of view, na-discuss ko na naman ito, the diameter of the area being examined. Or kumbaga kapag x-ray tayo, ito yung ating na-collimate. Diba yung ating may central ray or naiilawan ng light during x-ray. So ganun din sa CT scan, field of view is the area being examined. So usually 25 centimeters for a head scan. So there are different protocols for different departments or hospitals. So if we're going to compute for FOV, matrix size is multiplied by pixel size. So matrix size and FOV directly related. Pixel size and FOV directly related. Matrix and pixel size inversely related. So if you can remember what I have been discussing before, when they are on the same side of the equation, just like the matrix and the pixel size, they are inversely related. Pero pag nasa magkabilang equation sila, like FOV and matrix size, directly related. FOV and pixel size, directly related. So we have here another addition sa inyong assignment. So determine the FOV, matrix size is 512 by 512 and pixel size is 0.78 millimeters. So we also have the scan field of view and the displayed field of view. So dalawang klase ng FOV meron tayo. So ang scan field of view is the actual or yung mismong part ng patient. The actual area of interest scanned by the CT. So it determines the number of detectors needed to collect data for a particular scan. So kapag mas malaki yung area of interest natin, so maraming detectors ang kailangan. Or mas malaki rin yung kanyang matrix size. So the scan field of view or the SFOV must be larger than the area of interest. Siyempre, magbibigay tayo ng allowance. So hindi siya yung exactong ganun yung size. So, kailangan may allowance tayo on all sides, di ba? Para may hindi na-cut off. So, must be larger than the area of interest because any anatomy outside the SFOV won't be recorded and it will result in out-of-field artifacts or simple yung cut-off na tinatawag natin. So other term for SFOV or the scan field of view is calibration field of view. It determines the area within the country from which the raw data are acquired. Raw data kasi ito, as I mentioned, ito talaga yung actual area of interest. Another one is display field of view. this is the reconstruction field of view. So ito na yung field of view na dumaan sa computers and then mga adjustments na. So again, to make it clear, para simplify natin, scan field of view is the actual area of interest. Pero actually, mas malaki siya sa mismong area. Mas malaki siya ng konti lang. While the display field of view is the reconstruction field of view. Yung dumaan na sa computer and then na-reconstruct na siya. So while the display field of view increases the number of photons, so the noise is reduced, but spatial resolution also decreases. So if you can remember sa radiographic film, di ba, pag konti yung X-ray photon, so there will be increase in noise. So hindi maganda ang spatial resolution. Diba? So ganun din dito. So kapag malaki yung ating display field of view, maraming photons, so mare-reduce ang noise, pero mare-reduce din ang spatial resolution. So the DFOV can be equal or less of SFOV. So pwede pareho sila ng size, pareho sila ng output, or mas maliit yung DFOV, depende sa pag-reconstruct, depende sa protocols ng department. Yung SFOV is the area of measurement during the scan or the actual area. The DFOV, as the name implies, is the displayed image. So after being reconstructed, or after applying the reconstruction algorithm. So we also have here the Hounsfield unit. So other term for Hounsfield unit is the CT number. So we have discussed this, the prelim. So different parts of the body is assigned with different CT number or different Hounsfield units. So usually it ranges from negative 1,000 to positive 1,000. So negative 1,000 is air, while the positive 1,000 is a dense bone. So the value of 0, so 0 CT number represents water. So this is how we compute for the CT number, but never mind. We have already the constant value, just like what we have here. So I think I have given this to you as a prelim pala. So CT number versus the brightness level. So the lower the CT number, mas darker siya. The higher the CT number, mas brighter siya. Okay, ganun na kasimple. Like yung ating bones, so positive 1,000, so that is bright. While yung air natin, negative 1,000, so black siya. So for the shades of gray, the monitor can display only 256 shades of gray. So ang ating mata can only identify differences fewer than 40. So hindi aabot ng 50 shades of gray ma-identify ng mata natin. But the computer monitor can display up to 256 shades of gray. So human eye cannot appreciate contrast difference of less than about 10%. So the number display processor assigns a certain number of Hounsfield units or CT number to each level of gray. So yung monitor natin, as I mentioned, can display up to 256 shades of gray, and then gray levels sa monitor is assigned a specific Hounsfield unit. The number of Hounsfield units or city numbers assigned to each level of gray is determined by the window width. So I will discuss in a while the difference between the window width and the window level. So pag sinabi natin window width, so window width assigns the quantity of pixel values to the grayscale, while the window level determines the center pixel value in the grayscale. So to simplify, assume that we have 10 shades of gray available. Halimbawa, meron tayong 10 shades of gray. We have selected 300 as our window width. Halimbawa, i-select tayo ng 300 na window width. So, ang setting na yan is nasa control console naman ng ating computer. Therefore, only 300 of more than 2,000 possible density values in our scale will be represented on the image as a shade of gray. All others will be either black or white. So, ibig sabihin, if we have selected 300 as our window width, so ibig sabihin, if we have selected 300 as our window width, so yung bibilangin lang niya or ang i-display lang ng monitor is only 300 shades of gray. So yung iba na hindi nasakop ng 300, so they can either be black or white. Wala ng shades of gray. So for example, sa next slide natin, there are 30 different Hounsfield units grouped together and represented by each shade of gray in the image. So halimbawa, meron tayong ditong 30. The display processor assigned a group of Hounsfield units to each shade of gray. In this simplified illustration, 10 different shades are available to display the 300 Hounsfield units in the window width. So kumbaga kung magkakalapit lang yung mga shades nila, i-group sila into one para sa dinami-dami ng shades of gray, 300 lang yung i-display niya. Okay? Or pwedeng i-group niya, 10 lang i-display niya. So depende sa setting. So city number for bone is 1,000. For cis, that is negative 500, and so on. So next term is the window width. The computer allows for digital manipulation or window width. Yung window width and window level sinasabi ko kanina. The level of the window or the window level, so parang i-represent na yung bone window or soft tissue window or lung window. So para mas maintindihan natin, let's continue sa next slide. So a city number or Hounsfield unit to be distinguished as a medium intensity in the image is what we call the window level or the window center. So, bali yung other name for window level natin is window center. So, magkaiba yung window level sa window width. Okay? So the window level is normally chosen close to the average Hounsfield unit value of the tissue of interest. So for example, window level selected is 10 to 50. So parang range siya. This is the portion of the scale where the image is centered or tinatawag nga natin na window center. So it can be positioned anywhere within the window width and determines how bright the image appears. For window width, so na-discuss ko naman siya a while ago, range of city number displayed around the selected center and therefore determines the contrast. So we have here the relationship, narrow window width, higher contrast. Range of city numbers selected for grayscale amplification is also referred to as the window width. So, marami siyang definition dyan. So, the range of city numbers displayed in the image is represented by a grayscale. So just like what we have mentioned, it determines the maximum number of shades of gray. So sabi ko natin yun, halimbawa, pag 300, 300 lang shades of gray. Pag 100 lang, 100 lang shades of gray. So therefore, it determines also how much contrast appears in the image. So the window width and the window level are used, so they are both used to optimize the appearance of CP images by determining the contrast and the brightness levels assigned to the CP image data. So very, very important ang window width and window level or window center sa CP because silang dalawa ang nagde-determine ng contrast and the brightness levels ng image na naka-display sa monitor. So, discuss yan. So, ang sabi ko nga kanina, every hospital, every department, may sarili silang protocol. So, for example, so most common, just an example, for posterior fossa, the window width setting is 150, the window level is 40, and so on. So, depende yan sa, again, sa protocol ng isang department or hospital. For example, siya ng window width and window level. So, yung term natin, na-mention ko naman ito ng prelim. So, kapag puti, hyperdense. Kapag the same or between hyperdense and hypodense, ISO ang tawag. Kahit po naman kapag black, just like the air. So, na-discuss ko na naman yung CT scan components last time. Ayan siya yung kanyang cutaway view. Discuss na natin yan. So, another important term, so dapat niyong maging matandaan is the aperture. The aperture refers to the opening within the center of the country. So, yung butas kung saan pinapasok yung patient during the scan, we call that the aperture. So, usually, it is about 28 inches or 71.1 centimeters wide. Okay? So, mas malaki siya to accommodate different sizes of the patient. Another term is indexing. Indexing is a term which refers to the movement of the patient couch. Yung back and forth movement, yung up and down movement, sideways na movement ng table or ng couch or the patient support assembly, we call that the indexing. So movement, indexing, aperture is yung butas or opening. Ayan yung ating opening saan pinasok yung pasyente. Then, for detectors, so na-mention natin to before, a device that absorbs radiation and converts some or all of the absorbed energy into a small electrical signal. So, ang purpose ng detector para siyang, ito yung nagsisilbi nating image receptor. So, dinidetect niya yung X-rays na galing sa patient. Kasi di ba, i-expose ang patient, tapos yung useful or remnant radiation na mag-exit sa patient, i-detect ng detector para may image tayo. So detectors measure the intensity of radiation transmitted through the patient. In CT detectors, an electrical signal is proportional to the incident radiation intensity. So, ibig sabihin, kung gaano kadami yung radiation na na-emit ng patient, ganun din kadami yung signals na ma-receive ng detector and i-display sa monitor. The most common detector is xenon gas ionization detectors, consist of a gas-filled chamber with anodes and cathodes which are maintained at a different maintained at a potential, sorry, maintained at a potential difference. So when we say potential difference, it is the other term for voltage. So voltage na siya actually. So gas detectors are usually relatively deep and maintained at a high pressure to increase X-ray detection efficiency and are used in third-gen scanners. So these are examples of xenon gas ionization detectors. Another one, we have the scintillation crystals. Diba meron tayong gas ionization detectors. We also have the scintillation crystals. So the most common material used in solid-state detectors sa ating CT scan is cadmium tungstate. So this is an efficient X-ray detector. So again, pinaka-common or the most common detector, solid-state detectors used in CT scan is cadmium tungstate. Pero meron din iba, they are using cesium iodide, calcium fluoride, and bismuth germanate. Pero yung pinaka-common nga sabi ko is cadmium tungstate. Only solid-state detectors are used for 4th gen and up to 7th generation. Okay? Ito yung two general classification of detectors. So we have the solid state or yung ating scintillation detectors which requires power supply, have very high quantum and conversion efficiencies, and from the word itself, scintillation, they produce light when they are stimulated by X-rays. So the first crystal used in the earliest CT scanner was the sodium iodide. So later it was replaced by bismuth germanate, cadmium tungstate, and cesium iodide. So pinaka-common again is cadmium tungstate. The second one is gas detector. So hindi siya common sa CT scan. So it uses xenon gas. So these are the comparison between the solid state crystals, yung ating cadmium tungstate, and between the xenon gas. There are also three important factors contributing to detector efficiency. Ito yung mga factors na nag-determine kung gaano ka-efficient yung ating detector when it comes to absorbing X-rays and converting it into signals. We have the geometric efficiency, quantum efficiency, and conversion efficiency. Geometric efficiency refers to the area of detectors sensitive to radiation as a fraction of total exposed area. So, ibig sabihin, isang part lang siya, for example, ng detector. So, for example, sa lower one-third part, so tinitingnan kung gaano pa rin siya ka-efficient mag-detect ng radiation. So quantum efficiency refers to the fraction of incident X-rays on the detector that absorb and contribute to the measured signal. Yung quantum efficiency naman is tinitingnan kung ilang percent ng radiation ang na-absorb niya and converted into signal. While the conversion efficiency, ability to accurately convert the signals into electrical signals. So the overall efficiency is the product of conversion, quantum, and geometric efficiency. So i-multiply lang natin yan yung tatlo, then we can compute for the overall efficiency. So usually it has a value of less than 1. And the overall efficiency is also referred to as the dose efficiency. Another term is the data acquisition system. So interfaces detectors with the system computer and may consist of preamplifier, integrator, multiplexer, logarithmic amplifier, and ADC. So basta yung data acquisition system, binubuo siya ng different parts para pag nag-absorb ng X-rays, pupunta sa detector and then sa other parts ng ating uh, machine, then magko-convert siya into electrical signals. Hanggang mag-display siya ng image, we call that the data acquisition system. So, yung generator na ginagamit naman sa CT scan is either three-phase or high-frequency generator. So, between the two, mas preferred and mas ideal, mas efficient ang high-frequency generator, kaya lang mas mahal. Tapos na naman ito. Then, we have here accessories. So, yung mga accessories na ginagamit sa CT scan machine, we have the cradle. Ito yung nilalagyan ng ulo ng pasyente para maiwasan yung unnecessary movement during exposure. So, na-mention ko naman kanina, yung indexing is the movement. We also have the term image misregistration. So, from the word itself, para maintindihan na naman kayo, so this is an image distortion because of the movement of the table or the couch and or while the patient is breathing during scanning. So, mali yung magiging image para may motion artifact siya. Ganun. Another important term is what we call the pitch. So, pitch refers to the couch movement divided by the beam width. So, it determines the relationship between the patient couch movement o yung ating indexing kanina and the X-ray beam width. So, another term for pitch is helical pitch ratio. So, it is expressed in 0.5:1, 1:1, 1.5:1, and 2:1. So the difference is that, for example, a pitch of 0.5:1, so there is an overlapping images and produces higher patient dose. While a pitch of 2:1, so medyo matagal lang exposure, extended imaging, pero reduce naman patient dose. Okay? So we have here an example for calculation of pitch. So during a 360-degree, the tube rotation, 360 tube rotation, the patient count moves 8 millimeters, the beam width is 5 millimeters. So we simply plug the values. So 8 divided by 5. So the pitch is 1.6 is to 1. So na-discuss ko na naman ito. So this is an example of the control console sa CT scan. So yung patient is nasa kabilang room. We also have here terms such as reconstruction time. So from the name itself, this is the time between the end of the scan. So pagkatapos ng scan until makakita tayo ng image sa monitor. Another one is Fourier transformation. This is important. So in techniques, it is a mathematical procedure. So basta mathematical procedure siya, para siyang algorithm. Okay? Fourier analysis. So it analyzes the time signals that identifies the individual signal frequencies during the reconstruction. So we don't need to discuss more on this in detail. So ang purpose dito is that you will be familiar with this terms. Ito importante din na malaman niyo. So, standard slice thickness is 5 to 10 millimeters. So, patient dose for CT scan, so average is 2 to 4 centigrade. So, ang standard, so ang pinaka-common na ginagamit sa size thickness is between 5 to 10. But if you want high-resolution images, so we will use 1 millimeter, just like what I have mentioned earlier. We also use multi-format laser camera, special camera to transfer image to film. So parang i-print natin siya into film. Ideally, in a radiology department, the operating console and TV monitor is 2, 1 for the rad tech and 1 for the radiologist. Usually, dalawa daw yung monitor, isa para sa lab tech, para makita yung patient during the scan, mag-adjust ng mga settings, and the other one is for the radiologist na makikita niya yung image in real time habang nagsascan si lab tech. So the CT process can be broken down into three main segments. So data acquisition, from the name itself, we acquire data, we get data. Then after we acquire the data from the patient, so the image will be reconstructed. So of course, you can reconstruct the image using the data that you have collected. Then it will be displayed on the monitor. So yan ang pinaka-simplified na, na explanation ng CT process. Then we also have the term here, interpolation, a mathematical method of estimating the value of an unknown function using the known value on either side of the function. So parang ano lang, para siyang, when we say interpolation, parang nagsisolve tayo ng x. So isosolve natin yung unknown value using the given value. So yan ang ibig sabihin ng interpolation, which is used naman during reconstruction. And lastly, ito ilang beses na rin lumabas sa board exam. So this is the last topic. So the quality assurance. So for the device use, we have water bath. So ang purpose ng water bath is to measure the noise or the spatial uniformity, and it is done daily. Another one is the 5-pin insert. This is to measure the linearity and done monthly. Then we have the edge wire or hole array for spatial resolution, also monthly. We also use ramp for slice thickness to determine the slice thickness, kung okay pa ba siya, kung accurate pa siya. Monthly din siya ginagawa. We also have the slinger to measure the dose, of course, monthly din. And other devices for measuring the table incrementing, the light localizer, and collimation, also done monthly. So that's it. That is the end of our discussion of CT scan. So this is an overview. I am very sorry hindi siya ganun ka-detailed because of time constraints and because of what happened with the mechanics. So anyway, so ito lang yung publish ng ating exam sa finals for CT scan. So thank you and God bless.